Okay, good. Today we're going to go now the next step. We're going to be dealing with equations, and now yesterday we dealt with working with equations. What was an equation again? What was an equation? Yeah, what was that? Yeah, it's showing two equal quantities, right? Equal. We see that word in the word equation almost. Okay. Today we're going to really get to the heart of algebra. Okay. This is the core of what we're going to be doing throughout the rest of the year. We're going to see equations, and we're going to actually now have to solve for variables. Okay. I'll show you what I mean. A very simple type of equation that you would see would be something like maybe something like this. If I had 3 plus x, okay, 3 plus x equals, let's say 8, okay? Now, I know you could do this in your head. I know you can easily easily come up with the answer as that being 5, but there's actually a process that I'm going to want you to do, even on these simple problems, which should be somewhat mental math. I want you to go through these steps regardless, okay? Um, Now, there's a few terms that are going to become so familiar to you. They're probably not going to be familiar to you right now, but they definitely are going to be later. The first is isolating the variable. Say that. Okay, let's deal with the word isolate. When you think of being isolated, what does that mean to you? Like, what picture comes to your mind about being isolated? What? Being frozen? Are you thinking about isolated like ICE? No, that's not how we would spell isolated. I will isolate you with my freezing ray gun. Or no, that's not the right kind of isolate. In fact, that doesn't even exist. What do I mean by isolate? By itself. By itself. That's what I think about. When I think of isolated, I feel I get this picture of being like shipwrecked on an island all by myself with like buzzards floating around me, waiting for me to die or something. I'm isolated. I'm by myself. Okay. Now, in equations, and we know this, in equations, we do have an equal sign because that's the whole point of an equation is we are showing two equal quantities. We have variables, and we have what are these? Constants. That's right. So we have variables, constants, we have equal signs, and it's what we do with those variables and constants that matter. Okay, our first step with a problem like this is that we want to isolate the variable, which means we want to have this variable what? All by itself. That's right. Is it by itself right now? No, I have this plus 3 thing going on. Okay? So in order to isolate the variable, here comes another term that you're going to hear me say at least a billion times this year. Um, we want to do the inverse operation. Say that. Okay. Inverse means the opposite. It's another way of saying the opposite operation. So if I'm dealing with addition, the inverse of that would be what, class? It would be subtraction. Subtraction and addition are opposites. If I was dealing with subtraction, the inverse would be no. Will you listen to what I'm saying, people? If we're dealing with subtraction, the inverse would be addition. If I was dealing with division, the inverse would be, and if I was dealing with multiplication, the inverse would be right. So you get my point? And in the next 4 days, we're going to see examples of all of that. But today, we're going to be solving problems using subtraction. Subtraction. Okay, so here's how I would want you guys to do this. If I'm adding 3 to x, okay, what would be the opposite of that? I want to put x by itself, so I need to do the inverse operation, okay? What would be the opposite of adding 3? What would it be? Well, yeah, I guess that's one way of putting it. If I'm adding 3, the opposite of that would be to subtract 3. Does that make sense? So I'm going to subtract 3. Okay, he needs to get into his desk again. Can we please just not sit at that desk so we don't have to go through this every time Ryan comes back in to get his stuff? Every single time. Okay. So if I subtract 3 here, though, remember there's an equal sign here. What do I have to attend to? Remember I told you if we change anything on one side of the equal sign, what do I have to do to the other side? What, Talis? Same thing. It's the same thing. If I subtract 3 here, I need to subtract 3 here. And then I draw a line underneath it. Okay, these are the steps that I'm going to be wanting from you when it's your turn to solve these things. I'm going to draw a line underneath it. Now 3 minus 3 gets me what? 0. Nothing. There's nothing there except what? X is now all by itself. Consider it isolated. Okay? The equal sign is brought down, and then I have 8 minus 3, which gives me 5. So X equals 5. If we wanted to illustrate this, we could illustrate it. I have some little chips here, and let's say I've got my awesome variable that I made out of popsicle sticks and tape. Amazing what you can do when you need to. So I have 3 plus X. Yeah? You agree? And then I need what? An equal sign, and what on the other side? Got a little stack of maybe 8 chips. So we've got 1, 2, 3, 4, 5, 7, 8. Okay? So let's look at what we just did, with pictures, I guess, if you will. We wanted X all by itself. So logically, the only way to do that would be to what? Take it away, right? I'm going to take away 3 chips. You following me? Okay, if I did that on this side, I need to do that on this side. And so therefore, X equals what? 5. Okay? Simple as that. Now let's work with some more advanced problems. And by advanced, I don't mean that you're going to be doing anything different. It's just that you're going to be dealing with maybe larger numbers. But the process is still the same. If I have H plus 14, and that equals 82, what's the process here? Who could walk me through this process? Who thinks they have enough confidence in themselves to come up here and work this out according to what I just showed you? Mr. Mason, get up here. What's your question, Talis? Oh, no. It depends on what's over here. Now watch what he's going to do. Go ahead.
So this is 14, so the inverse operation would be minus 14.
Right, see?
Minus 14.
Uh-huh.
And I the 0, so...
You don't even need that 0. Just get rid of it. You don't want that messing up. Because sometimes, it could look like a variable. So H equals
68.
Now, could you prove this? Thank you. Good job. Could you prove that this is the answer? This is what I love about algebra. There is no excuse for missing anything with algebra unless you just took the easy way out. What could we do to prove this? Alyssa, you want to come up here and show us, or do you want to just tell me? Go ahead. What should we do? Right. If we know what H equals, then let's try it out. Let's put it in the equation. We have 68 plus 14, and then what? If you get the same answer as we did up here, which we did, then we know, without beyond the shadow of a doubt, that we did the right thing. So that's what I like about algebra. If you want to take the time, you can prove to yourself that you got it right. You got it right. I like algebra. When I was a kid, there was a lot of things I didn't do very well in math, and there was a lot of it that didn't make sense. But when algebra made sense to me, it was fun. I mean, it was almost like a mystery I had to solve. There's this unknown, and you got to go through these steps in solving for the unknown. And it was like a puzzle. It was more like a fun thing rather than it was sort of a drag of a thing. What happens if we reverse the equation? Where we come up with the answer first, like this: 81 equals 17 plus y. Does that make a difference? No. And I mean, don't be intimidated. Just say, hey, you know what? That doesn't intimidate me just because the answer comes first. It's the same stinking thing, What do I still need to do? Well, I got to look for my variable. Where's my variable? It's right over here. Okay? Is the y isolated? So what do I need to do? Well, then do it. On your whiteboard, start off by writing out the equation. That's what you always want to start with. Write out the equation and make sure you write out the equation properly. You would be amazed at how many people miss problems just because they didn't write the equation out. They didn't copy it out of the book properly. Are you all done now? Okay, well, you'll finish later and I'll scan it. All right. So excellent. I'm looking around and I see that everybody is saying, okay, the first thing that we have to do is we have to isolate the variable. So that means I got to get rid of the 17. But if I'm going to keep it equal, I need to do the same thing on the other side. So I'm going to subtract 17 from 81 as well. This isolates y. And 81 minus 17 is what, class? 54. You got it. Good job. Bang, baby. All right. We'll practice some more on our own here. Let's check them out. Is when we have to come up with our own equation. Because honestly, so far the equations have already been given for you. So therefore, if you know the process, then it's a pretty easy deal. But when we are given situations where we're faced with a word problem, then it becomes a little bit more difficult. Turn with me to page 41 again, and let's look at the map. There's a social studies application on the bottom of page 41, and it has to do with some of these coastal cities. We have this. I'll read, you guys just follow along. Dyersburg, Newton, and St. Thomas are located along the Ventura Highway, as shown on the map. Okay, so just study that map real fast. Look at that map because you're going to need to be able to know what it's talking about here. Okay. Find the distance between D, Newton, and Dyersburg. Okay, so here's what we know. What do we know? From Dyersburg to St. Thomas is how long? No. Look, from Dyersburg to St. Thomas is 25 miles. Okay? Now, from Newton to St. Thomas was how far? Okay, so this was 6 miles. So now, what we want to find out is how far is it from Dyersburg to Newton? And what are we going to call that? That says we're going to call that distance. So we don't know that. That's our variable. With your group, I want you to take these 3 bits of information, okay? We've got sort of a total amount, we have a sort of a variable, and we also have this constant right here. See if you and your group can come together and take all of that information in and create an equation. Okay, ready? Work on that together. Go. Okay, may I have somebody come up, show me their equation, and maybe explain how we would go about solving that. Alicat, you want to come up here? Come on up. I don't know. I like it. Because she's cool like that. Go ahead and just do that on the piece of paper, please. Right over there.
So I just write down?
Yeah, just write down and explain what you're doing. Listen up, guys.
I did D plus 6 equals 25 and minus 6. That is, and minus 6, which I got 21. And then so D equals 21 miles. So this equals 21 miles.
Right. And you know, I've always said too that when we're dealing with word problems, what we need to include in our words are what we need to include in our answer are always words as well, even if it's abbreviations like miles, which in this case would actually be MI, which would be fine. Okay, yeah.
It should be 19 years.
Oh yeah, you're absolutely right, Miss Allie. You messed up on your subtraction. You set up. Do we agree? Thumbs up if we agree the equation was right. Okay. The issue wasn't the equation. The issue was actually the what? The subtraction, and that's okay. It's an easy mistake. So instead of 21, it should actually be 19. So yeah, thanks for catching that. And and Allie is a great math student. It's just that even the best math students can make mistakes on these things. Okay.